Enjoy. Hey everyone, in today's session we start talking about measurements. We discuss perimeter, area, surface area, and volumes of geometric objects. Let's do it.
Okay, we are still busy with measurements. Now, in this session, I want us to talk about the measurements associated with 3D. So, we are talking about 3D object, 3D object, or object. Okay, now we need to understand that when we are looking at three-dimensional objects, we are no longer concerned with perimeter and area, but now we are looking at surface area, okay, which we normally write as SA, okay, and then we are also concerned about the volume, okay. Now, what is surface area? Surface area is simply the total area of the surfaces of the object. Okay, so we know that if this is the three-dimensional object that we are concerned with, the total surface area will be simply the area of this surface, area of that surface, area of this one, area of the base, area of that surface, and then the area of this other one. Okay, so it is simply just getting the areas of the faces and then adding all the areas together to get the total surface area of the object. Okay, and then what is volume? Volume is, let me just remove all of this. Volume is simply the amount of space inside a three-dimensional object. Okay, it's the amount of space within a three-dimensional object. So that is what we call volume. Okay. Now, the three-dimensional objects that we are going to be looking at, they are grouped or they are classified into two parts. There is what we call prisms, and then there is another one. It is called pyramids. Okay. But then for now, let's look at prisms. Now, what is a prism? A prism is shapes like this. Okay, so these are all prisms. Okay, these are all prisms. Now, what makes an object to be called a prism? So, an object is a prism if it has a base. Okay, so we can see that this guy is a base, the base is a rectangle in this case, and the base is exactly the same as the roof. Okay, so this is the base, which is the rectangle, but then if we look at this object carefully, we can see that the roof is exactly the same as the base. Okay, the rectangle, which is the base, is exactly the same rectangle that is on the top, or that is the roof. Another way of looking at this idea of pyramids is we can say that a pyramid is any object whereby the faces, when I'm talking about the faces, I'm talking about these guys, um, these ones, whereby the faces, okay, the sides of the object. So a prism is an object whereby the faces or the sides are perpendicular to the base of that object. Okay, so if that's the case, then we can classify that object as a prism. Okay, as we can see over here, that this is the base. Okay, this is the base, and all the faces, that face, this one, that one, and even that one, they are all perpendicular or at right angles to the base. Okay, because of that, then we can say that this guy is a prism as well. The same thing can be said about this one. The same thing can be said about this one as well. Okay, just remove these things. Much better. Just remove that. Okay. Now, before we talk about the total surface area and the volume of these prisms, let's just look at the naming. Like, how do we name these guys? Now, this one is named based on the base. Okay, so this guy will be a rectangular prism. This one. So this one is a rectangular prism. Rectangular prism. Why rectangular prism? Because the base is a rectangle. Okay. And then this guy, this one, is a square-based prism. Square-based prism. Okay. But then we normally call it a cube. Okay. So we just call it a cube. And then this guy is a guy that has a triangle as its base. So we can say it's a triangular prism. Triangular prism. Okay. And then this guy, of course, you can see that the base is a circle, but then we don't call it a circular prism. It has a special name. We call this guy cylinder. Cylinder. Okay. So these are the names of these three-dimensional objects, but then the names are not they're not very important. I just thought I should mention them for interest's sake. But then the very important bit is the bit on the surface area and the volume of these objects. Okay, let's talk about that. Now, the the surface area, it is very important for us to understand this, that whenever we are dealing with three-dimensional objects, it can be either a prism or a pyramid, it really doesn't matter. When we are looking for the total surface area of that object, what we do is we imagine as if that three-dimensional object is open. Okay, so we imagine as if the three-dimensional object is opened into its net. Okay, what do I mean by this? Let's take this one, for example. We imagine as if it is converted into a net like this, like that. Okay, and then the base will be here, and then it will be like that. Okay, now if it's like this, then we know how to determine the area of these two-dimensional objects, right? We can see that this guy is a rectangle, this is a rectangle, another rectangle, another rectangle, another rectangle, another rectangle. So if we have the the dimensions of the length, the width, and the height, then we know what to do. Okay, we will basically say length times breadth or length times width to determine the area of this guy, area of that guy, that guy, that guy, that guy, that guy, and then we know that the sum of those areas will basically give us the surface area of this rectangular prism. Okay, so that is how we deal with the idea of surface area in three-dimensional objects. Okay, so we'll do the same for this one. We'll basically imagine as if this is broken down into its nets, and then with that being said, you can see that the net will be composed, or the net will be made up of six squares. Okay, so we'll basically determine the area of one square and then multiply that particular area by six. Okay, and then that will give us the total surface area. Let's just write that mathematically. Okay, so if we want the surface area of this guy, for example, let's say this is the length, and then this is the height, and then this is the breadth or the width. Okay, now the total surface area will be the area of the base. Now the area of the base is length times the breadth. Okay, so it will be basically the area of the base, but then we can see that the base is exactly the same as the roof as we discussed earlier. So we will say 2 times the length times the breadth, because this essentially tells us that we are taking the area, we are considering the area of the base and the area of the roof. Okay. And then after that, we'll say plus, and then we say the area of this face, this one. Okay. Now we can see that the area of this face is basically the height times the breadth. Okay. And another very important thing to consider is that this face is exactly the same as that one. Okay. And because of that, we will just say 2 times the height times the base. Okay. And then last but not least, we have to consider this face. Okay. This one, which is exactly the same as that one. Okay, so because of that, we can see that we will have 2 times the length times the height. Okay, so it will be length times height in that case, and okay, just so it will be length times the height, and then that will basically give us the area of this guy and that guy. Okay, now this is basically the total surface area of this rectangular prism. So what is really cool about all of this is that we do not have to stress ourselves with remembering any formulas concerning the surface area of three-dimensional objects. The only thing that we need to master is the areas of two-dimensional objects, because if we master that, then we know ukuthi what we will basically do if we are given a three-dimensional object is break it down into its two-dimensional part, and then from there just determine the area of each 2D, and then after they just sum everything to get the total surface area. Okay, so that is how we do it. And yeah, okay, let's talk about this one. We can see that this is a cube, and for a cube we must know that all sides are the same basically because it is made up of squares. Okay, so this guy is the side, and then this is the side as well, and then that guy is the side as well. So basically what we see or what we can do is we can determine the area of one face or the area of one surface, and then we can multiply that area times 6 by 6, because we see that this guy has 6 faces that are the same as far as size is concerned. Okay, so we can say the surface area is equal to 6, and then times the area of one face. Let's take this one. Now the area of a square is side times side. Okay, so it will be side times side, which is side squared. Okay, so this is basically the area or the surface area of a cube, or the surface area of a square based prism. Okay, now the same thing can be done with this guy. Okay, because we can see that we have a triangle, and we know how to determine the area of a triangle. It's half times the base times the perpendicular height. Okay, so we will simply say 2 times the area of this triangle, Why I'm saying two times? Because the area of this triangle is the same as the area of this one. Okay, they're exactly the same size. And then after that, I can determine the area of this guy, which looks like a rectangle, and then I can determine the area of that one, which is the one on that side, and then I can finally determine the area of the other one, and then I can sum everything up to get the total surface area. Okay, now let's consider this guy, the cone. Now it's very important for us to to be imaginative in this case, or to use our imagination. Now, if I open up this cone, it will look something of this sort. There will be a circle, and then there will be a rectangle. Okay, and then okay, and then the same circle will be somewhere over here. Okay, so we can see that the surface of a cylinder is basically composed of the surface of a circle, of two circles that are exactly the same, and then the surface of a rectangle. Okay, so it will be basically be the area of the circle. So it will be two, say the surface area will be two times um, pi r squared, which is basically the areas of these guys. Okay, and then we can say plus the area of that one. Okay, plus the area of that one. Now, here we must be very careful because we have to recognize that this length, okay, so this guy will be, this length will be the same as the circumference of the circle. Okay, hopefully that is clear. I'm saying that this guy, if we envision it to be three-dimensional again, we can see that this one is the same length as the circumference of the circle. Okay, hopefully that is clear. And with that being said, we can basically see that this will be the height of the circle, and then this will be the circumference of the circle, the height of the the height of the cylinder. Sorry for that. The height of the cylinder. This is the height of the cylinder, and then this will be this part. Okay, this part, and it's clear that this part is the the circumference of the circle. So basically, what we will do is we'll say height times 2 pi r. Okay, 2 pi r, and then from there we know that this is the total surface area of a cylinder. Okay, so that is very important for us to know. So basically we didn't do much because we only broken this guy down into its net, and then from there we realized that the net is actually composed of two circles and then a rectangle, and then from there we just determine the areas of the 2D shapes, and then we just added them all together to get the total surface area. Okay, so that is what we do when we want the surface area. Now let's talk about volume. Okay, okay. Let's talk about volume. Now, to determine the volume is the simplest part compared to determining the surface area, because for a volume, what you need to consider is whether the 3D object is a prism or a pyramid, and then from there, after that has been established, you know which formula to use. Okay, so the general formula that is applicable to all prisms for volume is this one. The volume is equal to the area of the base, area of the base times the perpendicular height. Okay, times the perpendicular height. Okay. Now, by perpendicular height, I mean the height that is at 90 degrees to the base, or the height that is perpendicular to the base. Okay. So this is our base in this case, and therefore this will be our height. So this will be our height. And then in this situation, this is our base. Therefore, this will be our height. This is our base, and therefore that guy is our height. And then this is our base. This one is our height. Okay, so this is the general formula for determining the volume of any prism. Okay, now let's talk about pyramids. Okay, let's talk about pyramids. Pyramids. Okay, now what are pyramids? Okay, a pyramid is a three-dimensional object whereby the we have a base, of course we have a base, and then the faces. Okay, so we have a base over here, and then the faces, which is the other side. This is another color. Okay, which is the other side, this one, that one, and the other one. The faces are not perpendicular to the base. Okay, let me repeat. A pyramid is a three-dimensional object whereby we have the base, but then all the faces that are connected to the base are not perpendicular to the base. Okay. Or in other words, the angle between the faces and the base is not 90 degrees. Okay. As we can see that the the angle over here is not equal to 90, it's less than 90. This is not 90, and we can see that. Now, instead of us having a base and a roof. Here we only have a base, there is no roof. But then instead of us to have a roof, we have a point whereby all the other faces meet. Okay, we call this point the apex. Apex. Okay, so this is the point whereby all the other faces meet, but then most importantly is the fact that the faces are not perpendicular to the base. If that is the case, then we can classify that three-dimensional object as a pyramid. Okay, we can see that the same is applicable to this guy. Okay, this one and that one as well. Okay, you can see that. You can clearly see that. Okay. Now, when we are looking for a the surface area of a pyramid, we basically go through the same process that we went through when we are determining the surface area of a prism. In other words, we envision or we imagine that the shape has been broken down into its building blocks, so to speak. It's building blocks which are two-dimensional, and then we just simply add all of those together to get the total surface area. So let's me do this one as an example. First one. Now the first one we can see that the base is a square, I think. It looks like a square. Now, since the base is a square, we know that we can say that surface area. Okay. Let's say this one is side. Okay, and then it means this guy will be side, that one will be side, and then there'll be side as well. So the base of a square, or the area of a square, will be side times side, which will be side squared. Okay, and then another thing that has to be established is the perpendicular heights of these triangular faces. Okay, because remember that in order for us to be able to get a the area of a triangle, we need the length of the base and the length of the perpendicular height, or in other words, a height that is perpendicular to the base of the triangle. Okay, so we need the height here, the height there, and then we need um, a height there as well, and then another one for this face, and then another one for the other face. But then what we can see is that because the base is a square, then that automatically tells us that the base of this triangle is same as the bases of this one, same as the base of the other one, same as the base of the other one. And all of these triangles, they meet at the same point. So what does that tell us? It tells us that all these triangles are congruent, or all of these triangles are the same. They have the same area. Okay, because of that, we can capitalize on that or use that to our advantage. What we see or what we do is that we'll say 4 times the area of one triangle. Okay, the area of one triangle is half the base, which is side in this case, times the perpendicular height, which is h. Okay, and then we can say side squared, and then 4 times a half is 2. So it will be 2 times the side times the perpendicular height. Okay, so this is the total surface area of this guy. Okay, so the very same thing can be done for that guy, the very same thing can be done for that guy, and now with this guy. Now with this guy, it's a bit different. Okay, by the way, we call this guy sphere. um, I didn't name them. This one is a square-based pyramid. Square-based pyramid. Pyramid. Okay. This one is a triangular-based pyramid because the base is a triangle. Triangular. Triangular pyramid. Triangular-based pyramid. Base pyramid. And then this guy is a cone. Cone. And then this one is a sphere. Now, for a sphere, it's a little bit different because how we think about a sphere is we look at a sphere as something that is composed of something that is envisioned by combining four circles of the same size. Okay, so as a result of that, we say that the surface area or the total surface area associated with a sphere is 4 pi r squared, essentially the areas of four circles. Okay, 4 pi r squared. So that will give us the surface area of a sphere. Okay, now let's talk about volume. Let's talk about volume, 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 volume. Just move this. And then, okay, let's remove that. And then let's remove that. Right. And then let's continue. Now, for for pyramids, okay, as soon as we have established that the three-dimensional object that they've given us a pyramid, or as soon as we have established that this 3D object that is given has an apex, which is this thing, okay, that thing, that thing, that thing, or in other words, it's a pyramid. If we have established that, then we must know that you can use this formula for a volume. You can say that the volume is 1 over 3 times the area of the base, area of the base, area of the base, times the perpendicular height. In other words, the height that is perpendicular to the base. Okay, perpendicular height. Okay. So this formula is applicable to any any three-dimensional object that has an apex. So any three-dimensional object that can be classified as a pyramid. All right. Now let's talk about this guy, sphere. Okay. Now for a sphere, it's a little bit different because sphere doesn't have an apex, as we can see, so it cannot be considered as a pyramid. Okay. So the volume of a sphere the volume of a sphere is 3 over 4. Is it 3 over 4? 4 over 3? Mm, I think it's 4 over 3. Let's see. I think it's 4/3. Okay, it's 4 over 3 pi r cubed. Okay, so this is the volume of a sphere. Okay, so hopefully that is clear. The volume of a sphere is 4 over 3 pi r.
We've come to the end of our session. Please like and share our videos with your classmates, friends, and family members. Ensure that you follow us on all socials at XYZ Math Tutoring, and don't forget to subscribe to our YouTube channel. I have dropped the link to our YouTube channel on the comment section. Go check it out. Have a great day.